Example 3. Finding a tangent. Determine whether RA or line segment RA is tangent to circle E at E. So we have the given line segment EA, which is radius, line segment ER, which is 25 inches, and line segment AR, or the other leg, is 24 inches. Is triangle EAR a right triangle? EA squared plus AR squared is equal to ER squared. Substitute. 7 squared plus 24 squared is equal to 25 squared. Then simplify. 49 plus 576 is equal to 625. Are they equal? Yes. 625 is equal to 625. So it means line segment RA is tangent to circle E at A. Next, practice number 3. I want you to answer these questions. I'll give you 10 seconds to answer. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. What is your answer? Okay, from the first figure, the answer is no. Why? 4 squared plus 7 squared is not equal to a squared. How about the second figure? The answer is yes, because 2.5 squared plus 6 squared is equal to 6.5 squared.
In this problem, you will find the radius of a circle. What is the radius of circle C? Use the Pythagorean theorem. Substitute each side length into the equation. Why does the value x appear on each side of the equation? The length of segment AC, the hypotenuse, is the radius plus 8, which is on the left side of the equation. On the right side of the equation, the radius is one side of the triangle. Now simplify each side of the equation. Subtract x squared from each side of the equation. Then subtract 64 from each side. Now divide each side of the equation by 16. X equals 5. So the radius of circle C is 5.
Method number 3. What is the radius of circle O? So we have this given figure. Hypotenuse is x plus 6. The other leg has 10. What is the measurement of x? I'll give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. What is the answer? The answer from this Ch.12 is x equals 5 and 1/3. From x plus 6 raised to 2 is equal to 10 squared plus x squared. So we use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Then simplify. What is x plus 6 squared? So with the use of the whole method or by using distributive property, we can have the answer x squared plus 12x plus 36, or x times x is x squared, 6 times 6 is 36 from the last term, and from the middle term we have 6 times 2, 12 times x is 12x. So that's why we have x squared plus 12x plus 36 is equal to, what is 10 raised to 2? That is 100. So we have 100 plus x squared. Next, subtract x squared from each side. To get the variable x, or to isolate 12x, we will subtract x squared from each side. So we have 12x plus 36 equals to 100. Now subtract 36 from each side. We have 12x equals 64, because 100 minus 36 is 64. Next, x is equal to 5 and 1/3. We divide each side by 12 to get the unknown or the variable x. So the radius is 5 and 1/3.
Is segment CB tangent to circle A at C? Explain your reasoning. Here, we're trying to determine if a line segment is tangent to a circle. So let's begin by first reviewing what we know about tangent lines and circles. Recall, a tangent line to a circle is a line that intersects the circle at only one point. So if we have a circle and a line tangent to the circle, this tangent line will intersect the circle at exactly one point. Let's say it intersects at that point right there. That means that point is on the circle. So if the center of the circle is right here, that makes this segment a radius of the circle. The tangent line will be perpendicular to the radius of the circle. So our tangent line is here, our radius is here, and they're perpendicular. That makes this angle here a right angle. So take a look at our problem. Here, we have a triangle ABC. And notice, we know all three side lengths of this triangle. Point C is on the circle A. That means AC is a radius of this circle. If segment CB is tangent to the circle, well, the tangent line and the radius are perpendicular. That means this angle here would be a right angle. That would make triangle ABC a right triangle. That means if we want to determine if segment CB is tangent to the circle, we need to see if triangle ABC is a right triangle. If triangle ABC is a right triangle, that means segment CB is in fact tangent to the circle. If triangle ABC is not a right triangle, it means that segment CB is not tangent to the circle. So how do we determine if triangle ABC is a right triangle? Well, we know all three side lengths. Is there anything we can use to determine if this is in fact a right triangle? There is. We can use the converse of the Pythagorean theorem. So let's go ahead and review the converse of the Pythagorean theorem now. The converse of the Pythagorean theorem says, if there's a triangle and the two shorter sides are labeled A and B, and the longer side is side C, well, if the sum of the squares of the two shorter sides equals the longer side squared, that means this triangle is in fact a right triangle. So triangle ABC is a right triangle. That would make this a right angle, since side C is our longest side, the hypotenuse. Well, in order to use this theorem, we need to know A, B, and C. So let's go ahead and find A, B, and C now. In our problem, we want A and B to be the two shorter sides of our triangle. Well, for A, we could pick 10, or we could pick 24, either one. Let's go ahead and pick 10. So we'll set A equal to 10. That means B is equal to 24. And lastly, our longest side is C. That's 26. So C is equal to 26. Now that we have A, B, and C, we're going to go ahead and use the theorem. The theorem says if A squared plus B squared is equal to C squared, then we have a right triangle. Well, A is equal to 10. So we have 10 squared plus B is equal to 24. So plus 24 squared. And C is equal to 26. So we want to see if their sum is equal to 26 squared. 10 squared is equal to 100. 24 squared is equal to 576. And 26 squared is equal to 676. 100 plus 576 is 676. And 676 is in fact equal to 676. That means triangle ABC is a right triangle. And that means this angle here is a right angle. Since this is a right angle, that tells us that radius AC is perpendicular to line segment CB. That means line segment CB is tangent to circle A at point C. So we can say yes. Line segment CB is tangent to circle A at point C. So now we know how to determine if a line segment is tangent to a circle.
Problem number 4, identifying a tangent.
In this problem, you will identify a tangent. Is segment ML tangent to circle N at point L? Explain.
What we know, the length of the side is triangle LMN. They have the measurement of sides. We have from line segment NL, which is 7, line segment ML, which has 24, and line segment MN is 25. Think, what information does the diagram give you? LMN is a triangle, and we have the given measurement. And line segment NL is a radius. So what do we need to determine whether line segment ML is tangent to circle N? What is our plan? Line segment ML is a tangent if ML or line segment ML is perpendicular to line segment NL. Use the converse of the Pythagorean theorem to determine whether the triangle LMN is a right triangle. Substitute NL squared plus ML squared. Is that equal to line segment NL squared? Let's see. Simplify. What is line segment NL? Line segment NL is 7. So we have 7 squared. What is line segment ML? And that is 24. So we have 7 squared plus 24 squared. Is that equal to line segment NM, which is 25 squared? Okay, then simplify. What is 7 squared plus 24 squared? That is equal to 625. What is 25 squared? 25 squared is 625. Are they equal? Yes, 625 is equal to 625. So it means by the converse of the Pythagorean theorem, got it number 4. Question. Is line segment ML tangent to circle N at L? Explain. We have given triangle L and N. We have given radius, which is line segment NL, and that is 4. The hypotenuse line segment NM is 8, and the other leg is line segment LM, which is 7. I'll give you 10 seconds to answer this question. Timer starts now.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. What is your answer? Okay, the answer is this is not a tangent to circle N. This is by theorem or from the theorem of 12-2. We can use Pythagorean theorem to check. So NL squared plus LM squared is equal to 4 squared plus 7 squared. Simplify. 16 plus 49, that is 65. How about NM squared? NM squared is equal to 8 squared. So 8 squared is equal to 64. Since NL squared plus LM squared is not equal to NM squared, line segment ML is not tangent to circle N by theorem 12-2. Using multiple tangents, when a circle is inscribed in a triangle, the triangle is circumscribed about the circle. It means each side of the triangle is tangent to the circle. The tangent segments from each vertex are congruent. Have example. Let's have this example. Circle T is inscribed in triangle PUN. Find the perimeter of triangle PUN. So we have the given figure. PS is equal to PA, which is equal to 10. Next, NE is equal to NR, which is 25 centimeters. Next, line segment UR is equal to line segment US, and that is 4. What is the perimeter? So PN plus NU plus UP is equal to, by the definition of the perimeter, adding all the sides, and that is equal to 10 plus 25 plus 25 plus 4 plus 4 plus 10, and that is equal to 78. So the perimeter is 78 centimeters. Okay. For each polygon circumscribes a circle, find the perimeter of the polygon. Number 11. We have this given figure. I'll give you 10 seconds to answer this question. Timer starts now.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. What is your answer? Very good. The answer is 78 centimeters. Next figure. Again, I will give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. What is your answer? Very good. The answer is 76 inches.
In this problem, you will find segment lengths using a circle inscribed in a polygon. Circle O is inscribed in triangle A, B, C. What is the perimeter of triangle A, B, C? How can you find the length of segment BC? Find the segments congruent to segments BE and EC. Then use segment addition. Two segments tangent to a circle from a point outside the circle are congruent, so they have the same length. Segments AD and AF have the same length, 10 centimeters. Segments BD and BE have the same length, 15 centimeters. And segments CF and CE have the same length, 8 centimeters. Now use the definition of perimeter, P. Use the segment addition postulate. Now substitute.
Got it 5. From the figure, circle O is inscribed in triangle PQR, which has a perimeter of 88 centimeters. And what is the length of line segment QY? I'll give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. What is your answer? Okay. From theorem 12-3, Px is equal to Pz, which is 15 centimeters. Rz is equal to Ry, which is 17 centimeters. So Qx is equal to Qy. 88 is equal to Qx plus Qy plus Px plus Pz plus Rz plus Ry. By the definition of perimeter, we need to add the sides. We need to substitute. So 88 is equal to Qx plus Qy plus 15 plus 15 plus 17 plus 17. Then simplify. So 88 is equal to Qx plus Qy plus 64. Subtract 64 from each side. So QX plus QY is equal to 24. Now, 12 is equal to QX is equal to QY. Since QX is equal to QY and QX is 12, QY is also 12 centimeters. So the length of line segment QY is 12 centimeters. Thank you for listening. If you have any question, just send me a message through Schoology. Have a great day. Bye.